Okay, so next I have been asked a couple of questions from a few people on question 8, so I'm just going to do it on 2011. Okay, so firstly you're asked describe the mechanism for the monochlorination of methane. So I think we're all okay with that. Again, if not, let me know and I'll post it up. What you're looking at, initiation. Cl2 in the presence of UV light splits into 2 chlorine free radicals. These chlorine-free radicals attack a methane molecule, forming a methyl-free radical. This methyl-free radical then attacks another methane molecule, forming another chlorine-free radical. A chain reaction occurs, and termination is when these chain reactions, when these free radicals combine. The question I have been asked is the evidence of this reaction, okay? And I'm just going to bring you up here to the book, and this is on page 413, okay? And firstly, it is that the reaction takes place in UV light, okay? So if we look here, that's the first piece of evidence. And how do I know that? I know that because firstly it won't take place in darkness, and then secondly is that I know that I have 2 free radicals broken down. The next one here then is that the explanation for a chain reaction, the evidence for that is that for every photon of light I have thousands of these chloromethane molecules formed. The next explanation is that if my free radicals are present and in the termination phase they combine together and they form ethane. Well, the evidence is that ethane is found in my products for those methyl free radicals actually being formed. The next one here then is that if I add a source of my free radicals, okay, it's going to speed up the reaction. It acts as a catalyst. And obviously here then, by extension, if I can speed up the reaction, remember rate can be altered, okay, so it can not only be sped up, but it can also be slowed down. So an inhibitor is something that slows it down. So again, I can slow it down by using oxygen. So if we were looking here at our evidence, the easiest evidence is that firstly, the reaction occurs only in UV light. Okay, and does not occur in darkness. That's the first one. Okay, the next one then is that I have ethane in my products. And the fact I have that ethane in my products means that my methyl free radicals are formed and combine in termination. Okay, and remember, if you're chlorinating ethane, butane will be formed. Okay, so just to keep that in mind. And finally then adding something like tetramethyl lead, and that speeds up the reaction. Okay, so they are your 3 biggest pieces, really the easiest 3 to remember. Again, just remember, if you're chlorinating ethane, it's tetraethyl lead, and that list is on page 413. It is also in your notes. Next here then, we're asked to explain when we're told that we are making ethene can be passed by passing ethanol vapor over hot aluminium oxide. Name the type of organic reaction involved in this conversion. Okay, so if we look here, it's elimination, the making of a smaller molecule from a larger molecule, leaving a double bond in the smaller molecule or in the molecule. And then you're asked, list the bonds broken and the bonds formed. So I'm going to have a look at this. This is my ethene. This is my ethanol, apologies. And I'm going to look at my ethene, and water is also produced. So if I look here, first, that's broken in ethene. I see no OH anywhere here. Okay, so the first bond that's broken is OH. The second bond that's broken, if I look, I have 1, 2, 3, 4, 5, and I've only 1, 2, 3, 4. So the second bond that's broken is C to H. And if I go over here, there are all the bonds broken. My bonds formed then. If I look here, I have a C double bond here that I didn't have there. So that's my bond that's formed. And finally here, if I look at what I have here, I have one OH, which is the OH here. But I also have another OH. So that's my bond formed there. So that's my answer to part B. And part C then, you are asked to describe your bonding in benzene. Okay, and this is probably fairly basic in that, remember my benzene, I have 1, 2, 3, 4, 5, 6. And my ring here, and often just indicated like this. Okay, so if I look at this, all of these have one hydrogen, okay, on them. So what I have is, I have all of these are carbon to carbon sigma bonds. Okay, so all of these are sigma bonds. Remember, sigma bonds head-on overlap. Okay, so there are my sigma bonds. I also have carbon to hydrogen sigma bonds. Okay, so again, sigma, 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 and sigma. Okay, and then what I have inside here, okay, each one of these carbons still have one electron, and each one of these electrons is in a pi bond. Okay, and a pi bond is a sideway overlap, and these are delocalized. So we've delocalized pi electrons. Okay, that's it.